Hello, friends, and welcome to ARC 1010, a classical architecture workshop with Professor Paul Monson. This lecture is called Sacred Geometry, Exploring its Archetypal Language and Origins. What do we mean by sacred geometry? Have you ever come across that phrase before? And what is an archetype? An archetype is like the original, or the pattern, or the model that other things are based on. It's a prototype, a perfect example, a template, a recipe, a symbol. So we're going to look at geometry differently than you probably did in school, looking for symbols and meaning, and maybe even reality itself. Of course, any pursuit of truth and reality must begin with Calvin and Hobbes. So Calvin says, I don't think math is a science. I think it's a religion. Hobbes says, a religion? Yeah, all these equations are like miracles. You take two numbers and then you add them, they magically become one new number. No one can say how it happens. You either believe it or you don't. This whole book is full of things that have to be accepted on faith. It's a religion. And in the public schools, no less. Call a lawyer. As a math atheist, I should be excused from this. And Calvin's right, there's a great mystery and wonder in math that we kind of pretend isn't there and just do our homework. What we call math today is a mundane and secular shadow of what it meant to ancient Greeks or Egyptians or other civilizations. Today we're taught math as memorizing procedures to get one answer and pass a test. But the roots of the word mathematics comes from Greek and meant learning in general, or to be aware, or even to awaken. Ancient Greeks like Pythagoras were engaged in deep studies of natural science and self-understanding. They were interested in more than just adding and subtracting basic quantities. They were interested in the relationship between math and nature. Nature, that garden of wonder and the ultimate teacher. If we slow down and observe the world around us, one of the first things we notice is that within this incredible variety, there are repeating types or archetypes. There's an underlying order governed by geometry. So no two specimens of a pine cone or a sunflower or spider web or any of these things is exactly the same, right? And yet it isn't just random chaos. There are many, many individual specimens we can measure and understand with our senses, but our mind tells us through reason that there's an unseen, constant, somewhat mysterious type or pattern that's just as real behind each physical example. The philosopher Plato called these constant types the forms. There are many products, many physical examples of a thing, but one form. If we can understand the symbolic or sacred geometry in nature, the patterns, proportions, and numbers that are woven into the tapestry of plant and animal life, then we'll start to see how those same patterns and archetypes can be applied to things we create, whether art or jewelry or quilts or architecture. Leonardo da Vinci gave us this wisdom in the Renaissance. Quote, if you do not rest upon the good foundation of nature, you will labor with little honor and less profit. Those who take for their standard any one but nature, the mistress of all masters, weary themselves in vain. So how do we study this relationship of number and nature? How can we get at these forms and patterns? Geometry is the bridge between the one and the many. In ancient manuscripts and paintings, you frequently find images of God like this. Historians call these God the geometer or God the great architect. What is he doing? He's taking some kind of instrument in his hand and measuring or drawing a circle with this watery planet-like structure inside it. What is it in his hands? It's a compass, one of the primary tools of geometry, which literally means to measure the earth. If you're familiar with Pompeii, an ancient Roman city that was buried in 20 feet of volcanic ash in 79 AD, those who rediscovered Pompeii in the 17th and 18th centuries found everything like it was, frozen in time underneath. And guess what tools they found in the office of an architect, the one who designs the buildings? They found compasses and squares, among other measuring tools. So these tools have been around for a long time. And today we're just going to play with the compass and square. Well, we'll just use one edge of the square, a straight edge if you don't have a full square. But the square is a straight edge with two sides that form a right angle or 90 degrees. But the two tools that you need for today are a compass and at least a straight edge like an architect scale or a ruler. From Genesis, the Middle Ages, and beyond, the Abrahamic religions viewed God as the divine architect who measured, weighed, and laid out the blueprints of the cosmos. For the believer, divine order permeated the universe and bore record of its creator. In this tradition, to design, create, or build is a privilege and honor where the architect approaches a role similar to the gods. In other traditions, we find a similar pattern. Fuxi and Nuwa are the brother-sister deities of Chinese mythology who created humanity. Both hold the instruments of the architect, the compass in the hand of the female and the builder's square in the hand of the male. Let's talk a little about these tools before we start using them. First of all, they are ancient and found in every culture in the world and used by artists, craftsmen, engineers, and architects. So they are useful and universal, but they're also symbolic. Every time you use them, it can remind you of the creation of everything preceding you. The ruler or square works in the horizontal domain down on the paper and connects points that are found by the work of the compass. If you'll pick up the compass, you can see the two ends, one with a point and one with a writing instrument. It works in the vertical domain, pointing down from above. Medieval geometers considered the compass as a symbol of light and grace shining down from heaven like rays. The pointed end pokes into the paper to make the center of a circle, which is, of course, a curved line that stays the same distance from that center at all times. So feel free to go ahead and try it. Go ahead and make some circles on your paper. You can pause the video if you'd like. Make circles, some small and large, some separate or connected. See what you can come up with if you try to create some designs, interlocking circles. Each time, make sure you press the point in the paper, pierce the paper so that the center stays fixed, and then hold it steady. And that distance from the center to the curved line stays fixed so the pencil comes all the way around to enclose a perfect circle. A circle is often a symbol of heaven. It's infinite, it's perfect, it has no beginning or end. Indeed, the word universe derives from the Latin words for one turn. The circle is sometimes called the mother of all shapes because just with this little compass and straight edge, you can create all the subsequent forms and patterns. They're all contained within it. It represents the origin of everything. You could say that the compass circumscribes everything, all truth, all creation inside one great whole. Here's wisdom from the East. Lao Tzu in the 6th century BC. The Tao gives birth to the one gives birth to the two gives birth to the three gives birth to the 10,000 things. In other words, the natural world is all connected. It's all generated from the same origin or unity. Nature is infused with geometry and beauty that reminds us of this origin. And if we want to know how to design something like a building, the answers are actually right in front of us, hidden in plain sight, as it were. The way to generate beautiful designs, 10,000 designs, infinite designs that resonate with other human beings is to design them the same way that we are designed, the same way that things in nature are designed with geometry and proportion as our guides. In fact, neuroscientists have studied this, and to the brain, there's essentially no difference between looking at a building designed this way or looking at a tree. Both have layers of fractal like detail based in geometry. To look at them can be an experience of pure wonder and delight. As the English poet William Wordsworth wrote, "Come forth into the light of things. Let nature be your teacher." And so, as we embark on this journey together to become architects, let us do so with humility and respect, even a little reverence for nature, for the architecture we've inherited. Here's an 1840 painting by Thomas Cole titled The Architect's Dream. In this painting, he tries to capture the vast history of architecture from the ancients in the far distance to the Gothic revival of his day in the foreground. As I have mentioned to others, our program here at UVU is rooted in this history and classical tradition. For us here in the United States, that tradition runs through Egypt and Rome and Greece and Europe, primarily in England, and then to the neoclassical and the founding of our country. But every culture has its classical tradition. Africa, Asia, the Middle East, the Pacific Islands, based on these same universal principles found in nature. They're both complex and very simple at the same time. Complex because there's so much variety, just like in every class at UVU, we're each unique individuals. But simple because in the end, we're all cut from the same cloth, so to speak, patterned after the same archetype. So if you've ever wondered how the universe was created, and by extension, how you can create something as sublime as this, we're going to answer that question today. Well, maybe not completely, but symbolically, at least. As our friend Michael Schneider put it, as legal residents of the cosmos, we have the authority to view the world's blueprints. Here they are, construct the patterns that construct the universe. Let's begin with the number one, which in Greek was called the monad, like monarch or monorail. One of the first things that a child often draws when he or she gets tired of scribbled is something that loops back on itself. They love to trace the outline of a cup and see a perfect circle. The circle symbolizes the number one. It's a glimpse into the ideas of wholeness, unity, and divine order in the universe. See how close you can get to a perfect circle by drawing it freehand before we start using the compass. As a kid, we all had that experience of tossing a rock into a pond and watching the ripples expand outward in concentric circles from that single point. This idea is found in the creation myths of many cultures, which begin with expansion from a divine center. You could also think of a seed from which a tree grows. Nothing exists without a center around which it revolves, like a nucleus of an atom, the hearth of a home, the capital of a nation, or the sun of a galaxy. A center is singular, there is only one. And what we often do in class together is to think about numbers differently than we usually do. Starting with this number one, we think of numbers as quantities, one, two, three, four. But these quantities also have qualities, right? So we can describe what the concept of one is like. And so we'll do it as a thought experiment for this presentation. Think about the qualities of the number one. Think about some things that might come to mind. For the number one, we might think of unity. We might think of wholeness. We might think of singularity. We might think of things like being alone. There's that song, the one is the loneliest number, right? Think of things that one makes you feel or think about. And then let's draw the symbol for one together. On a clean sheet of paper, to construct our symbolic universe, we start with a point. And it's worth stopping and contemplating a point for a minute. Anything we draw or create is not actually a true point. You can put it under a microscope and it has volume and shape, unlike the true idea of a point, which has absolutely no dimension, length, or height. We can't create the ideal with our human tools, but we can symbolize it. So think about that point as the seed unfolding a sacred mystery about to expand. And then with the pencil and try to turn the full circle in one complete rotation. How did you do? You just completed your first assignment for the class. Congratulations. Uh, see how easy it is? There are some things that can go wrong. First, if your center moves, then your circle is going to not return back to the origin. And second, if the opening size of the compass changes, so make sure that that opening size stays fixed. Hopefully you have a compass that has a wheel on it that can lock it in place. If you get a really cheap compass, it's going to drive you crazy trying to keep that opening constant. But if something went wrong, don't erase it. Just get a new sheet of paper and try again. And when you're happy with it, you write your name in the bottom right corner and the word monad. So for each of our exercises, you'll write the word monad, dyad, triad as we go, etc. And also your name underneath that. And before we move on, a few final thoughts about unity and the circle. You know, in geometry, the relationship between the radius and the circumference is the irrational number pi. 3.1415926, etc. Some people have memorized it to lots of decimals. So it's an irrational number. If either the radius or the circumference is measurable in whole numbers, then the other is irrational. It's a number of endless decibels, which suggests to me that if this is the origin of everything we create, then everything has a rational and irrational aspects to it. It's a paradox. Creativity is both limited and unlimited at the same time. Let's think about circles around us. At a giant macro level, there are circles in the heavens. This is a time-lapse photo of the stars with the North Star at the center, which is often referred to as the nail of the heavens around which all things rotate. Planetary orbits, as well as the shape of the sun, moon, and earth, are circular. Well, actually, they're elliptical because nature is full of subtle changes from the expected and the simplistic, but basically circular. And in the earliest surviving book on architecture, Vitruvius in ancient Rome counsels architects to learn astronomy. He says the architect should be equipped with knowledge of many branches of study and varied kinds of learning. Let him be acquainted with astronomy and the theory of the heavens and courses of the stars. The ancient architect was expected to understand the circular courses of the stars, and buildings were often patterned after the heavens or the cosmos. One of the most famous ancient examples is the building in Rome, still the world's largest masonry dome, called the Pantheon. If you drew the architectural blueprints for the Pantheon, you would find it's all based on the circle. The floor plan, top left, elevation, top right, and sections at the bottom. The entire structure is created from the archetypal geometry of the circle, making it a perfect sphere inside. Standing inside and looking up at the coffered dome ceiling is quite mesmerizing. It's like a beautiful illusion of perfection. And as the sun draws its own circle across the sky, it traces an arc on the walls and floor through the oculus in the dome. Just as nature delights in circles, so do we. The Pantheon is one famous example of people creating and responding irresistibly to circles, cylinders, spheres. Circles are everywhere around us. I remember one time opening my fridge and just counting all the jars and bottles and objects that are based on the circle. It's almost creepy. That oculus reminds me of the pupil of our eyes. Isn't it interesting that the instrument through which we perceive all of creation is itself a circle? Circular structures are common in religious structures. Here are examples from China and India and Rome. So, for our purposes in architecture, there's more to a circle than just a curved line. Religious art and buildings return again and again to the circle to symbolize the divine, eternity, enlightenment, the axis mundi or center of the world. Sacred circles and spirals denote a meditative journey toward their center. From prehistoric carvings at Newgrange, the Labyrinth at Chartres Cathedral, or the spiral jetty here in the Great Salt Lake. Architectural ornament almost always begins with a circle, like the repeating guilloche motif here, which is itself used in classical architecture to symbolize eternity. We say a conversation is pointless, not because it's going nowhere, but because it has no center to hold it together. All creating starts from a center point, and so that unity resides quietly inside all things. We know this mathematically because any number multiplied or divided by 1 remains itself. 3 times 1 is 3, 1,000 times 1 is 1,000. Unity is the common denominator of the universe. And just for fun, does anyone know the answer to this math problem? 111,000,000, 111,000, 111 times itself. Another proof, if you will, that starting with unity, with 1, you can create all the rest. The result is 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's move on to the number 2, the dyad. Let's do the same thing we did with number 1, thinking of the qualities of two-ness, what words or ideas come to mind. Heraclitus said, "From things that differ come the fairest melodies. All things are born through strife." So we may think of two as conflict or harmony and resolution, opposites. When we think of the number 2, we think of duality, a mirror image, a duplicate, a copy. Dropping two pebbles into a lake causes ripples of energy to flow through the water, and at a certain point, they begin to overlap and create a third shape. When two circles overlap, they create an almond shape known as the Vesica Piscis or Mandorla, which has a long history of religious and symbolic association. Let's construct the Vesica Piscis, the symbol of number 2, of two-ness, the dyad. Start with a large circle on your paper, and then place the point of the compass on the circumference of that first circle, keeping the opening size the same. We're going to draw a second circle to the right of our first circle. This is the drawing to symbolize the number 2, or the dyad. So write the word dyad and your name underneath it in your best architectural lettering, and you can scan that and submit it to Canvas. As we do these constructions, the important points to keep track of are intersections and the centers of our circle. And as we've drawn this second circle to the right of the first one, if we connect these centers of the two circles and connect the intersections, we found two lines that are at a right angle, showing that we didn't even need the square to find right angles. We found that just with the compass, and these circles. In biology, we observe mitosis, the process of creation where a single cell duplicates to give birth to another cell. You could think of it as duplicating or as dividing. Either way, the result is two. Again, we see that almond vesica shape in the birth of something new. The Vesica Pisces, which translated literally means fish bladder. It was often adopted by Christians as a symbol of Jesus, who was the intersection between God and man, heaven and earth. He was the mediator, just as the Jewish temple rituals likewise mediated and bridged the gap between the sacred and profane, the divine and the human, or the spiritual and the material world. Medieval architects adopted the Vesica shape in cathedral design, which is widely known today as the Gothic arch. This shape was used in the major royal portals for church entrances. Passing through these portals, visitors would symbolically be reborn into the kingdom of God through Jesus as they entered the church. In other instances, such as Chartres Cathedral, the enthroned Christ hovers above the door as the gatekeeper within the Vesica Pisces. And we'll see in later classes that the Vesica shape has a relationship with the root 3 rectangle and the equilateral triangle, and mathematical ratios that define the proportion of Gothic architecture from the floor plan to the structural bays, like this example of the Chartres Cathedral. Or an American example from the Latter-day Saint tradition, familiar to many in Utah. This is a window from the temple in Kirtland, Ohio, near Cleveland. And just for fun, another American example proving once and for all that our football is superior to the other football. This ball is clearly a more sophisticated shape, right? So to review where we've come so far, we covered the first two numbers. We observed how the point and the circle orient us in the world and symbolize unity and eternity. And here are a couple of additional examples. In Islam, the orientation of a person in space is of supreme importance. This is evident in the Muslim ability at all times to be aware of a Qibla, or direction in which Mecca lies, and toward which devout Muslims pray 5 times per day. No matter its location in the world, each mosque is carefully oriented toward Mecca and the sacred center found in the Kaaba. At Stonehenge, we find everything oriented around the circular movements of heavenly bodies, the sun, the moon, and stars. All of our geometric constructions will begin with unity, including duality. And we saw how 1 becomes 2 through a process of multiplication or division, like 2 pebbles dropped into a pond, or the biological process of cell division. How about the qualities of 3 and 4 and beyond? Well, 3 we call the triad. What things come in threes? What's threeness like? Think about that for a minute. There's a tension with 2. It's often associated with opposites. Remember how the philosopher Heraclitus said all things are born out of strife. Light and dark, high and low, big and small. With things in tension, there can either be a winner and a loser, or you can introduce a third thing, a mediator, something to reconcile or synthesize the 2 extremes. One thing is too hot, the next is too cold, the third is just right. There's a classical concept from Aristotle in ancient Greece who pointed out that virtue is often found in the mean between 2 extremes. For example, courage is the mean between cowardice and recklessness. 3 has a quality of completeness and perfection. When we start a race, we say, ready, set, go. And we say, it's as easy as 1, 2, 3, not as easy as 1, 2, or as easy as 1, 2, 3, 4. We can observe the number 3 in various types of flowers, like this lily, which is actually 3 nested groups of 3, giving us a beautiful layered grouping of 9 petals. Fruits and vegetables often organize their seeds or structure according to 3s, like these melons, cucumbers, and peppers. And clovers, which remind us of the geometry of the triangle. Historically, some cartographers placed Jerusalem at the center of a 3-petaled world map because of its importance for the Abrahamic religions. Mountains break the flat horizon, reaching up like a symbolic triangle and pointing back down in their reflection. In architecture, the pyramids of Giza are perhaps the most obvious example of this archetype of the triangle. Triangles are inherently stable. Think of the three-legged stool, which is far superior to the two-legged stool. If you've ever done the engineering experiment to make a bridge out of paper, you know that one way to increase the strength is to fold it into triangles, like a fan, which is really a series of small arches. We might not think of arches as related to threes, but it's actually a wonderful illustration because you take these two sides coming together, and until they connect together at the center with a keystone, they can't hold up any weight. So, as Leonardo da Vinci said, an arch is two weaknesses which together make a strength. Threes can create more complex architectural compositions as well. Here's a lovely example from the Italian Renaissance, the Church of San Ivo, Sapienza in Rome, by the Baroque architect Borromini. The dome is created with overlapping triangles that alternate convex and concave. Or this architectural ornament of three circles, also by the architect Borromini, but in the Church of San Carlo al Quattro Fontane, a pattern for the Trinity, but also a pattern for how we construct the triangle using three circles. So let's draw threeness together. And with all these constructions, you're welcome to pause the video at any time in order to complete the drawing. To start, we'll draw the same construction we did for the dyad, starting with one large circle, marking the center point, and then to the side of that circle, placing the point of the compass on the circumference of the first circle, drawing another circle that goes through the center of our first circle, and then finding the intersections. So if we find the intersection where those circles overlap, place the point of the compass at that intersection and draw another circle above. It will go through the centers of those first two circles and with our straight edge, we can connect those 3 points, forming an equilateral triangle. This is the symbol for three. You can write the word triad on your paper and put your name on it and submit this as your drawing for the number 3. Once we found this equilateral triangle, we can start creating more patterns with it, extending the lines out till it connects with our original circles, finding more intersections, the equilateral triangles multiply. We can find this pattern of 4 equilateral triangles, which will lead us to the number 4 that we're about to explore, the tetrad. Nature uses as little as possible of anything, said Johannes Kepler. For the first time with 4, we're able to escape the flat surface and create something with volume. This little four-sided shape called the tetrahedron brings the triangle's stability into the third dimension with minimal materials, minimal sides, minimal corners. It's the most stable and strong of all solids. A diamond at the atomic level is a series of carbon atoms with tetrahedral bonds, which makes it the hardest naturally occurring substance and best conductor of heat. If you've ever seen someone cut concrete or stone, you've seen a diamond blade in action. But the first shape that comes to mind with 4 is probably not the tetrahedron unless you're really a geometry nerd. It's probably the square, right? We draw the numeral 4 as if on a 2 by 2 grid. The ancient Greeks noticed that 2 plus 2 is the same as 2 times 2 and used it as a symbol of justice because of its balance and equality. The earth below us, solid ground, terra firma, is the ultimate symbol of strength and substance. We divide it twice, north-south and east-west, into 4 quadrants. And we often hear the phrase, the 4 quarters of the earth. The circle with a cross in the center has long been the astronomical symbol for planet Earth. We quarter not only space, but time, dividing the year into 4 seasons based on the relationship of the sun with the earth around the 2 equinoxes and 2 solstices. Winter, spring, summer, and autumn, an eternal cycle of 4s. We represent the archetype of the tetrad sometimes without even realizing it, like when we walk on sidewalks divided into squares that symbolize the earth they cover. Early American frontier town planning reveals the same rational square grid pattern. Town planning efforts by Latter day Saints, for instance, placed an emphasis on a sacred center with what was called the Plat of Zion. In fact, anyone who's visited Salt Lake City learns quickly that all physical addresses are in relation to the temple block at the city center. Many other cities in Utah are gridded the same way, with addresses given as numbered coordinates like 300 south and 900 east. We might take this for granted, but it is following ancient patterns where fourness mapped onto city plans with four quadrants was common. Ancient Roman cities located the Forum and temple at the intersection of the two major cross streets, the Cardo and Decumanus, creating a sacred center for the city. A similar pattern was used in Spanish colonial town planning with the laws of the Indies, with a central plaza marking the religious and political center of the town. These planning principles can be seen in the Florida town St. Augustine, which is the oldest continually inhabited city in the United States, as well as in Washington, D.C.'s four quadrants and the Sacred Heart of the city and nation, being marked by the U.S. Capitol. Ancient philosophers saw the natural world divided into four elements: earth, water, fire, and air, sacred symbols that represent four parts of our soul. On the walls within the cube-shaped Holy of Holies are depictions of vegetation that help to reinforce the notion of a heavenly paradise. The cube shape itself is expressive of perfection, perfection of deity, and the typical shape of a heavenly temple. When sacred spaces have incorporated the patterns found in the cosmos, they speak a language familiar to us. For the ancient world, there was an inextricable link between temple and cosmos, heaven and earth. For Hindus, the plan of the temple corresponded to not only the human body, but the universe at large, with the most sacred deities at the exact navel of the structure. This famous drawing by Leonardo da Vinci is called the Vitruvian Man and shows how both the square and the circle are contained within the proportions of the human body, just as with temples. As we get into architecture, we'll find this relationship in the classical tradition, where the beam or entablature above the column has a proportional relationship to the column of 1 to 4. The classical orders were seen as representing not only the proportions of the human body, but gods and goddesses, saints and patrons, as we can see quite literally here at the Acropolis, where the ancient Greeks embraced this symbolism on the porch of the Erechtheion. So in constructing the square, again, we're going to begin with unity. Start with that first circle, then divide or multiply that circle to the side using the same circumference. We find our intersections of those two circles. And if we connect those dots, remember we find that those two lines that cross each other at 90 degrees. Where they cross is another intersection. And this is the first time that we're going to change the opening size of our compass. So now it will be half as large, and we'll put the point of the compass at that intersection where we've dropped the vertical and horizontal lines, and draw a circle half the size, which also has intersections with our vertical line. And if we connect those 4 points, it's a perfect square. Turned 45 degrees, sometimes we call this a diamond shape, but it is a 45 degree square. Okay, so we've traveled through the point of the monad, the line of the dyad, the triangular surface of the triad, and the volume of the tetrad. What's left? Well, pretty much everything. Even though there are some living things that are as simple as a line or triangle or square, they're rare except at a microscopic level. Most of the visible life around us has much more complex patterns with higher numbers. With 1 to 4, we established the foundation of structure and volume, and now we can really make things come alive. The ancients called 5 the quintessence or the breath of life. So with numbers 5 through 12, we'll be exploring pretty much the rest of the universe, all the plants and animals and heavenly bodies and everything around us. If you watch the video by Lisa DeLong, she talks about 5 in her opening example of the apple cut at the equator. Inside are 5 seeds arranged not randomly, but in the shape of the 5-pointed star. We think of the 5 fingers and toes on our hands and feet, or the starfish. Then we start noticing fives in all kinds of natural objects, some obvious, like the five-petaled flower, and some less obvious, but equally beautiful. Another example from Lisa DeLong's lecture, the planet Venus traces this perfect five-petaled pattern above us in the sky. This cycle takes 8 Earth years to complete, or 13 Venus years. So we have the second planet from the sun and the third planet from the sun, creating this five-petaled design every 8 Earth years or 13 Venus years. If you write those numbers down, 2, 3, 5, 8, 13, you may notice a certain sequence of the numbers. It's the Fibonacci, or part of the Fibonacci sequence, which actually begins with 0 and 1, or unity. Then you add the first two terms to get the next term, then repeat with the next two terms, and so on. At first, we just see a sequence of numbers, but what is really interesting is the process by which they're growing. They grow based on a relationship from within itself, nothing external. And we can try to quantify what that proportion is. Proportion is the ratio of two numbers. So take one number and divide by the other. If you do that, you'll find that the numbers get closer and closer to actually another irrational number. This is called phi, Phi, also known as the golden ratio. And that is 1.61803, et cetera, et cetera. This is the second irrational number we've encountered. The first was pi, which is the circumference and the radius of the circle, that relationship, and this is phi, both very important in these geometry constructions and proportion, which tells us that design is partly irrational, right? We can never quite define it or put limits on it. The golden rectangle is the only rectangle where you can subtract a square from it and it remains the same proportion. Entire system of Western music is based on the same Fibonacci sequence. 5 black keys in groups of 2 and 3, 8 white keys, plus 5 black keys, giving us 13. And with those 5 black keys and 8 white keys, you can compose endless melodies and harmonies, symphonies, operas, the whole history of Western music. When we connect the points of a pentagon, we find a five-pointed star, which has sides in golden relationships all over. Every green line to the red line in each drawing is a relationship of 1 to phi, or 1.618. Architecture uses the geometry of 5, sometimes overtly, other times more subtly and symbolically. The five-pointed star, known as the pentagram, can be found on numerous Christian buildings, with the 5 points representing the 5 wounds of Christ, or 5 nails used in the crucifixion. The cruciform plan of the church is laid out according to the parts of Jesus' body. The or the golden spiral can be viewed in plant and animal life, to the curl of waves, weather patterns. It's also alluded to in the Ionic classical order at the bottom left. This proportion, based on dividing something into 5, is important in both the proportions of the human body and in the classical orders of architecture. In this drawing by my friend Joseph Bricky, we can see the unit of measure that was used anciently, called the cubit, from the elbow to the fingertips. In the classical tradition, the height of an ideal man was considered to be 4 cubits. And when you raise your hands above your head into the heavens in prayer by lifting sacrifice into the air, you can add 1 cubit to your stature, making 5 cubits in total. That fifth part, the fifth cubit, has an equivalent in architecture, where the proportion of the entablature, or the beam that rests on top of the column, is 1/4 the height of the column. 4 parts for the column, 4 cubits for the height of the body, and a fifth part for the entablature, representing the heavenly realm. This 4-to-1 ratio is found among all 5 of the classical orders: Tuscan, Doric, Ionic, Corinthian, and Composite. There it is, 4-to-1, 5 total parts. The construction of 5, the pentagon, is a lot trickier than the others because we have to find that phi relationship. It's a very specific ratio, and you have to be very accurate and careful in your drawing, or it will be slightly off. So I recommend doing this one rather large on your page, which gives you more room for error. Start with our drawing of unity and divide it into duality. So we have these two circles side by side. We can find the intersections and centers, mark all of those. Connect those points to find our horizontal and vertical lines. Find the intersection in the center. and draw that smaller circle half the size, which intersections at the top and bottom. Now, do the same construction that we did at the larger scale, now at half size. So draw a circle to the right of that smaller circle you just completed. And that also has intersections. We can drop a vertical line, find the center of that smaller vesica shape. And this is the first uh, move that we need to make with our compass, where some people can get lost, but you want to put the point of your compass at the center, that intersection of the two lines in the smaller vesica shape, and then the pencil of our compass at the top of that circle right in the middle. And we're going to draw an arc down until it hits the horizon line, that horizontal line in the middle. Now take the compass and we're going to change size of it one last time. So we want the point of the compass now at the top of that circle and the pencil at that new intersection where the arc went through the horizon. And that is an opening size that will divide that center circle into 5 equal divisions. 1, 2, 3, each time placing the point of the compass at the next place circle intersected. 4 and 5. There's our symbol for 5, the pentad, which you can write on your drawing and add your name to it to submit your drawing here. You can connect those 5 dots to create the pentagon. Well, that takes us through the number 5. Mircea Eliade said, reality is the imitation of a celestial archetype. Let's move on to the number 6. There's an ancient Egyptian saying, as above, so below. The 6 is the hexad. We can see this hexad or hexagon in snowflakes, honeycomb, turtle shells, daffodil flowers. Insects, such as the honeybee, crawl on 6 legs and build their homes out of 6s. In architecture, in ancient Rome, 6-pointed stars and hexagons can be found in ceiling details, wall panels, and floor mosaics. Here's examples of the use of the 6-pointed star in Armenia that range from its use in the plan of a medieval church of the shepherd to the dome of monasteries and even in architectural detailing. Known as the Seal of Solomon or Star of David, the 6-pointed star was eventually adopted on Israel's national flag. Muslims know the hexagram as the Seal of Solomon. Both Solomon and David were prophets in the Old Testament, and both are mentioned in the Islamic holy book, the Quran. The hexagram appears in Islamic artifacts and mosques worldwide. Unlike the pentagon, the hexagon is really easy. We haven't had one this easy since 3, which is, of course, a factor of 6. So they're very closely related. To draw the hexagon, we're going to start with our diagram of duality and draw 2 circles side by side. And if we take that same opening size of our compass, we can continue to draw these circles around the circumference of 1 in the middle that crosses. We have an intersection, and you'll notice that there are 6 intersecting points. So we can connect those and draw the hexagon. If we connect the points of the hexagon, we'll notice how it's related to 3 with these equilateral triangles. And this fierce-looking lion guarding the Forbidden City in Beijing holds in its paws a sphere decorated with a pattern based on 6, known as the Flower of Life. So since that hexagon was so easy, let's draw the Flower of Life as well. If you can go back to your diagram of 6 and place the point of the compass at those other sections around the circumference of the original circle, you'll notice that it draws this pattern in the middle, flower of life motif, a six-petaled flower. And you can find that motif in every culture in the world. It's easy to double it if you find the midpoint between the petals, and we can go around the circle again to create the dodecagon or 12-sided figure. So while we're on 6, let's do 12 as well. If you draw a line, that ray from the center of the circle in the middle, out from there until it passes through the point of the intersections on the outside, and see where it intersects our circle, bisecting those points on the six-petaled flower. We can draw the same six-petal flower pattern again, overlapping to create this pattern of 12. And think about 12 for a minute. What are some things that would divide into 12 around a circle? Obviously, time. Time on a clock is divided into 12 hours for a day. And in the heavens, we divide the year into 12 months. We divide distance also into 12, with 12 inches in a foot. 12 seems to be quite useful for measuring things, partly because we can divide easily into 3, into a whole number, right? 10 is difficult to divide into by 3, but 12 gives us a nice whole number. It has so many numbers that can be divided by evenly. The factors of 12 are 1, 2, 3, 4, and 6. 12-sided polygon, the dodecagon, can make all kinds of shapes: squares, triangles, and hexagons. As our Earth orbits around the sun, our view of the constellations changes for each of the 12 months of the year. And we know what month it is because of the constellation, which is behind the sun when it rises. The constellations and astrological signs kind of have a reputation for being a little new agey, superstitious, so we won't say too much about them other than to acknowledge that for most of human history, we were much more connected to the stars and orbits of heavenly bodies than we are now. And the representation of the heavens on our earthly creations, including the decoration of buildings, is a common way of lifting the mind to higher ideals. 12 can be abstracted to its pure geometry or combined with other motifs, as in this ancient Roman mosaic from Sicily, where the intricate tilework forms 3 interlocking squares surrounding laurel wreaths and fruit, representing abundance. And I think it's worth pausing for a moment just to admire the hundreds of hours that it would have taken to create something like this by hand. Incredible. In the Old Testament, we read of a brazen sea in Solomon's temple that sat on the back of 12 oxen, a tradition that's carried on today in baptismal fonts of some Christian churches, including temples of the Latter-day Saints. Many tribal nations, including Israel, were divided into 12 tribes, and the camp was laid out with 12 sections, much like the way ancient cities in China, Egypt, and Greece were divided into 12 districts. One last note about 12, pardon the musical pun. If any of you are musicians or learned the piano as a kid, you'd recognize the circle of fifths and fourths, these intervals and notes that relate to each other based on simple geometry and proportions related to 12. Each of these intervals that make different harmonies between notes also form different polygons and patterns. Have you ever seen a clock like this before? With all these powerful associations, especially to the heavens, there have been times in history when the number 12 was seen as too symbolic. This was a clock they came up with during the height of the secular French Revolution in an effort to remove from timekeeping the number 12 with all its connections to the heavens and God and the king. Instead of 12, they declared that the day would be divided into 10 equal hours. The year would be 10 months, and instead of 7 days in a week would be 10 days, so there wouldn't be a Sabbath anymore. Obviously, this didn't stick for measuring time, but it did with other things like distance and weights and other measurements. The metric system, right? All based on the number 10, as we know, which became the dominant system of measurement in the world. It was started by the anti-religious French Revolution. Numbers are powerful things and affect culture in ways that we may not realize. Speaking of 7 days of the week, let's return to our counting. After the number 6, we reach heptad, or the number 7. 6 circles surround a seventh perfectly. 6 days of creation and the seventh day of rest. There are 7 coils in the traditional labyrinth. The 7 color spectrum consists of red, orange, yellow, green, blue, indigo, and violet. The moon's phases are counted as 4 sevens to make 28 days. There are 7 stars in the Big Dipper, which help us find the North Star. On the temple in Salt Lake City, there are depictions of the moon's phases in the Big Dipper constellation. A continuous 7-day cycle runs through history and was first practiced in Judaism with its root in the biblical 7-day creation cycle culminating in the Sabbath. The Greco-Roman gods were associated with the days of the week and named after the 7 classical planets visible to the naked eye. To construct the heptagon, we're going to start again with unity, divide it into duality, and draw that vesica shape in the middle. And the division of our circle into 7 parts is simply half of the height of that vesica shape. So if you take your compass and you open it so that it is exactly the height of half of the vesica shape, then take that measurement, take that distance, and start walking the compass around the circumference of the circle. It will divide that circle into 7 equal parts. And that is the heptad, which is your drawing symbolizing the number 7. Moving on to 8, or the octad. 8 is the first cubed number, 2 times 2 times 2. In a musical scale, the 8th note is the octave. The octave is a pitch that is exactly twice the frequency of the lower note. So it's the note that begins a musical scale over again. We find 8s in the structure of jellyfish and sponges, flowers, crustaceans, spiders, and of course the octopus, an animal basically synonymous with its number of limbs. There are 8 phases of the moon, represented here in a stained glass skylight. Chess is played on an 8 by 8 grid. In the Eastern tradition of Feng Shui, the map is divided into 8 areas or energies, corresponding to the cardinal points north, south, east, west, and their medians, northeast, southeast, etc. Many historic buildings, from churches to castles, are organized as an octagon, including the interior of our friend the Pantheon in Rome, in the bottom center here, and the Dome of the Rock in Jerusalem. Christian baptistries were often 8-sided, representing the 7 days of creation and the 8th day as a rebirth and a new beginning. In Islam, the inhaling and exhaling of the compassionate Allah is represented by the pattern of 8 pointed stars and crosses. Let's draw our symbol for the number 8, the octagon. It's no surprise we'll start with unity and division into duality, just like we have in the past. Finding those intersections gives us a horizontal and vertical line that cross at a 90-degree angle in the center. We can find that point and draw the circle half the size. It's kind of like this diagram of an eye turned on its side. And that intersects the vertical line in 2 places, at the top and the bottom. Just like we did with the number 5, we'll draw that same smaller circle to the right. But now let's draw that same circle to the left. At the top. And also at the bottom. You'll notice that we've created this 4-petaled flower in the middle. Taking your straight edge, we can connect these points on a diagonal. And where those points intersect the circles gives us 8 equally spaced points to form our octagon. And feel free to go back and pause the video if you need a little more time to draw each of these steps. You can rewind the video and watch how to do it. But that's our octagon, or the octad, and you'll write the word octad and your name on this drawing to submit that. Moving on, the number 9, or the ennead. This is not a word that we hear very often. The octagon is quite common, but the ennead, has anyone heard the word ennead before? There's a kind of a popular personality theory called the Enneagram, if you've heard of that, where there's 9 basic personality types. The word 9 and new are associated in various languages. Before we're born, we develop in our mother's womb for 9 months. Each centriole within a cell is composed of 3 microtubule stacks arranged around a circle in 9 bundles. Here's an incredible blue mosaic dome ornamented with a 9-pointed star pattern in Iran. The accuracy and precision is astounding. I mean, imagine starting on one side and going all the way around and being able to complete this pattern perfectly back at the origin. Here's a 9-pointed defensive wall around the town of Palmanova in Italy. The 9-story Mayan temple at Chichen Itza symbolized a belief in 9 cosmic levels: 4 above, the earth in the center, and 4 below. Chinese magic squares are associated with 9 archetypal principles of number and mirrors the supreme order of the universe. This also plays out in ancient Chinese city planning with a divine center dedicated to the supreme cosmic ruler. How to construct the nonagon, or the ennead. So with this construction, we're going to create our symbol of unity, the circle, divide it to one side. And just like we did with 6, we're going to draw another circle to the side of that. So we have these 3 circles side by side. And this was our diagram for 6, but this time we're going to connect some different points than we did before. Using your straight edge, you can connect these points to get these 2 overlapping equilateral triangles. And then we need to find intersections of those 2 triangles and draw from the point of the triangle opposite lines that go through the intersections on the other side. And we'll do that for each of the sides of our triangles that overlap here. 3 times. Extend those lines all the way out to where they cross the center circle. We'll find these points and our circle evenly into 9 sides. This is the ennead, E-N-N-E-A-D. So you can write the word ennead on this diagram, symbolizing the number 9, and your name, and submit that. We're almost done, just 2 to go. Number 10 and 11, since we already did 12. And let's pause here to consider the words of the Renaissance architect Leon Battista Alberti, who was audacious enough to try and define beauty. Today, we just dismiss beauty as this old-fashioned notion as being in the eye of the beholder. That's certainly what I was taught in public school growing up. So I was quite surprised when I got to architecture school at Notre Dame, which also teaches the classical tradition, and someone said to me that no, beauty is not entirely subjective. It's actually an objective quality, and the purpose of beauty was to bring us back into unity with the divine. That idea really changed my life and my whole approach to design. Alberti wrote a lot about beauty in architecture, and this is how he defines it, which I think is a pretty good definition. Said, I shall define beauty to be a harmony of all the parts, in whatsoever subject it appears, fitted together with such proportion and connection that nothing could be added, diminished, or altered, but for the worse. So we've come to the number that maybe we most associated with the kind of math we did in school, which is done with the base 10 numbering system. Thomas Jefferson said, when angry, count to 10 before you speak. If very angry, 100. Wise advice. It's No surprise, the word 10 comes from the Indo-European word for two hands. We count to 10 using our 10 fingers, and if we need to count higher, well, I guess we have to take off our shoes and count our 10 toes. The Colorado blue columbine flower charms pollinating insects with its two sets of 5 petals. And DNA has 10 steps along its double helix, which creates a 10-sided rosette. The decagon, with its overlapping pentagons, can be handy for creating geometric patterns. But 10 also has the tendency to become static and repetitious. In our modern world, in the endless pursuit of efficiency, we've converted almost every measuring system into the power of 10, from money to weights and measures in the metric system, like we discussed earlier. This has been called the decimalization of number, reducing everything down to a system of decimals, which can kill other systems with all their rich potential for pattern and relationships. But let's construct the decagon in spite of its dangerous tendency to take over everything. If you remember the pentagon, we'll do that construction kind of twice, reflecting it upside down for the second time. And the construction for the pentagon was tricky, but the second time around, maybe we'll go a little smoother. Drawing our symbol of unity and duality, two circles side by side, connecting the vertical, finding that intersection. Then taking our compass at half the size and drawing a smaller circle inside that same circle second time to the right. So we do the diagram at a large scale, the same diagram at a half scale, and then finding that intersection of those two circles, dropping that vertical, and we find that point right there in the center of that smaller vesica shape, which we can open our compass now to the distance from that center of the vesica to the top of the circle in the middle, and drop an arc down until it hits the horizon. That is the opening size, if you'll recall. That size right there will divide our circle in the middle into 5 equal parts. 1, 2, 3, 4, and 5. It should return to the one of the points that is on the circumference of that circle, divided equally into 5. So we have this pentagon. We found that already before. Now what we need to do is take the halfway point and keep our compass at the same size. If we draw a pentagon upside down, it will divide each of those distances along the circumference in half. And we can continue marching along the perimeter circle until we find this pentagon that's upside down. Those two, that's our decagon. Finally, we come to 11. So let's draw the hen decagon, the hen decad, and we'll talk about the mystery of 11. 11 is a little tricky. Again, we need to be very accurate with our compass or we'll lose our way. Starting with our two circles side by side, drawing our vertical and horizontal. Draw the same circle down below. And this is the distance that we need to find here, the distance between those two intersections. It's a slightly larger circle. Where that intersects, we're going to draw another circle here. And that distance there is the measurement that we need to divide our circle into 11 parts. So if you compass now and work your way around the circumference of that circle in the middle, it should continue and the circumference 11 times equally for our hen decad. You have to be quite accurate with this. So if you were a little off on your initial measurement, go back and start again. to complete this pattern, decad, and you can connect all of those points for an 11-sided figure. To conclude our lecture, we're going to look at an ancient math puzzle where the goal was to take these two symbolic shapes of the circle and square and bring them into unity by drawing a square and a circle that have the same area using just a compass and a straight edge. It's represented in this famous drawing by Leonardo da Vinci showing the proportions of the human body. It turns out you can approximate it, but it's very difficult to do it perfectly. So you may hear that phrase, squaring the circle, referring to something impossible. Squaring the circle is almost impossible in an absolute sense, but one approximation of the square and circle brought into this unity of equal areas has to do with the number 11. When the square has a side equal to 11 and the circle has a diameter of 7, the areas are very close, 7 and 11. 7, 11, which of course brings us back full circle to that divine icy confection, the ultimate symbol of eternity, the Slurpee. No, just kidding. 7-Eleven convenience stores have nothing to do with sacred geometry, although Slurpees are delicious. But the Great Pyramids of Giza in Egypt actually do. The Egyptians considered the relationship between 7 and 11 sacred. The pyramid's height to the length of its base has a relationship of 7 to 11, or 0.636, which also happens to be a pretty close approximation of the golden ratio, and amazingly is related to the sizes of the Earth and the Moon. So if you stack the Moon and the Earth on top of each other, the triangle connecting their centers and the Earth's circumference is a special triangle. We call it the Kepler triangle. So I'll leave you with this image to contemplate as we conclude our journey from 1 to 7-Eleven. I mean, 1 to 12. This has been a fun ride. I know most of it was like a fire hose coming at you. And as we wrap up, just remind us that nature really is the guide as we continue on in design, so that everything that we create has this relationship to our own bodies, to flowers and trees and mountains and things in the earth and in the heavens at a cosmic scale, at a microscopic scale. Return back to geometry. If you feel lost as you're designing something and feel like you're wandering in strange roads of the arbitrary and don't know how to find your way, come back to geometry, and it will be a constant guide for you and help you to create things that will resonate with other people. And I thank you for your time. Hope that you've enjoyed this presentation on archetypal and sacred geometry.